Hi, I am Karen. My friend, Sulji Lee, a doctoral student in Department of Chemical Engineering, made this presentation slides. Today I will present this on her behalf. The title of the paper is Effects of Vertical and Horizontal Configurations of Different Numbers of Brush Anodes on Performance and Electrochemistry of Microbial Fuel Cells. This paper was published in Journal of Clean Reproduction in 2020. The presentation is organized as shown on this slide. Introduction. Microbial fuel cells (MFC) are an innovative environmental and energy system that convert organic pollutants in wastewater into renewable electrical energy. Currently, MFC is being developed for next-generation energy-positive wastewater treatment. For practical implementation of an MFC for next-generation wastewater treatment, MFC performance should be enhanced greatly. To further increase the wastewater treatability and energy production rate, optimizing electrode configuration is very important. Various anode structures and materials were tested to investigate their effect on MFC performance and electrochemistry. A cloth electrode assembly with a separator between the cathode and anode was tested, and it produced a maximum power density of 1195 mW per square meters in a cubic reactor. The CEA can reduce the reactor volume, but the anode surface area is too small to harbor sufficient exoelectrogenic biofilm. Carbon felt anodes with titanium wires or stainless steel mesh were tested in a single-chamber MFC. It shows that the larger current collector of stainless steel mesh is advantageous in a short-term power generation and disadvantageous in a long-term performance, because the larger current collector interferes with mass transfer and microbial growth. A carbon cloth anode, an anode cathode assembly, and two brush anodes with different arrangement were tested in a single-chamber cubic MFC. They provided comparative quantification of performance, polarization resistance and impedance of the 5 anode types. The brush anodes produced better performance than the carbon cloth anodes, and they implied that solution resistance affect anodic ohmic impedance. 5 brush anode arrangement were tested in a single-chamber cubic MFC to investigate effects of the brush anode arrangement on performance and electrochemistry of MFC. The anode installed horizontally to the cathode with the closest distance produced the highest performance. The horizontal anodes showed higher energy recovery and treatability than those of the vertical anodes. In previous studies, both size and number of brush anodes were changed at the same time, thus it was not clear which factors influenced MFC performance. In addition, no experiments have been conducted on anodes vertically placed to the cathode so far, and there were no comparative investigation of the vertical configuration and the horizontal configuration of anodes. In this study, by using brush anodes with the same size, effects of number and configuration of the brush anodes on MFC performance and electrochemistry were investigated. To find effective ways of anode installation, 4 brushes were installed parallel to the cathode or perpendicular to the cathode. For a strict and accurate comparative electrochemical analyses, various electrochemical measurements were conducted, such as polarization test, electrochemical impedance spectroscopy, and cyclic voltammetry. Materials and methods. Electrode and reactor fabrication. An activated carbon cathode was used. The cathode electrode was made of stainless steel mesh coated with a carbon-based catalytic mixture. A carbon fiber brush anode was made with carbon fibers and a titanium core rod. 1 ACPVDF cathode and 4 brush anodes were assembled into a reactor vessel along with 1 reference electrode. 1, 2, 3 and 4 represent brush anodes, and R represents a reference electrode. Inoculation and operation. 4 brush anodes were inoculated in the MFC reactor with a slurry mixture of effluents from the primary settling tank and activated sludge tank at Gwangju wastewater treatment plant. Then, the anodes in the cathode were connected to 1000 ohm external resistor for inoculation. When the MFC voltage exceeded 100 MV, the internal solution was replaced with 50 mm phosphate buffered saline medium containing 20 mm sodium acetate. Subsequently, the MFC medium was replaced when the MFC voltage decreased to less than 10 MV. For MFC operation, a 50 ohm external resistor was used, and the MFC voltage was measured using a multimeter. The brush anodes were inoculated and matured in the MFC for 2 months. Electrochemical tests. To investigate the effects of number and configuration of the brush anodes on the MFC performance and electrochemistry, 4 brushes were installed parallel to the cathode or perpendicular to the cathode. Polarization curve measurement, IS, and CV were performed using a potentiostat. For the polarization tests, the MFC was operated with a 50 external resistor for 3H after the medium was changed. IS of the anode electrodes and CV for the anode was also performed in a 3-electrode configuration. An alternating voltage with an amplitude of 10 MV and a frequency range of 10 to the 5 to 10 to the -2 Hz was used for the anodic impedance measurement. CV tests were performed in 3 cycles, and the final CV result was used for data analysis. Results: power and current production. As the number of brush anodes parallel to the cathode increased in the horizontal configuration, power and current densities also increased. The maximum power density was highest for H4, 1925 mW per square meters, followed by H3, 1855 mW per square meters, H2, 1718 mW per square meters, and B1, 1212 mW per square meters. The maximum current density was highest for lowest H4, 13,252 mW per square meters, followed by H3, 13,162 mW per square meters, H2, 11,516 mW per square meters, and B1, 8,044 mW per square meters. However, in the vertical configuration, the power and the current increased when the number of brush anodes was increased to 2, but decreased when it was increased to 3 or 4. The maximum power density was highest for V2, 1436 mW per square meters, followed by V3, 1398 mW per square meters, V4, 1335 mW per square meters, and B1, 1212 mW per square meters. The maximum current density was highest for V2, 10,038 mW per square meters, followed by V3, 9,799 mW per square meters, V4, 9,553 mW per square meters, and B1, 8,044 mW per square meters. Polarization resistance. As the number of horizontal brush anodes increased, the anodic polarization resistance decreased. However, the cathodic polarization resistance was almost constant and was not affected by the number of anodes. The internal resistance decreased as the number of brush anodes increased, owing mainly to reduced anode resistance. When a second brush anode was added perpendicular to the cathode vertical configuration, the anodic polarization resistance decreased dramatically. The internal resistance and the optimal external resistance decreased dramatically when the second brush anode was added. Anodic impedance. To more accurately analyze the anodic internal resistance, IS was performed at the optimal potential for each anode, at which the MFC produced the maximum power. As the number of horizontal brush anodes increased, both the anodic ohmic and charge transfer impedance decreased gradually. In the vertical configuration, the addition of a second brush anode greatly decreased both the anodic ohmic and charge transfer impedance. CV analysis. The CV results showed that adding brush anodes increased the current production in both the horizontal and vertical configurations. There were not much difference of the current production between the two configurations. Discussion. Power and current production. In the horizontal configuration, when the number of brush anodes increased, power and current productions increased, but not in proportion to the number of brush anodes, because the area of the cathode was constant. Compared with a single brush anode, B1, max increased by 59%, IOP by 67%, and Imax by 65% in H4. However, in the vertical configuration, power and the current productions were maximized at the two brush anodes. Compared with B1, max increased by 18%, IOP by 24%, and Imax by 25% in V2. In a multiple anode set, different distance between an anode and a cathode can cause different anode performances. When anode performances are different in the multiple anode set, electron generated from a stronger anode can flow into a weaker anode, called current reversal. The current reversal was also detected in a serially connected stacked MFC when substrate concentration was relatively low in one cell. In a small single-chamber cubic reactor, different numbers of brush anodes, 1, 3 or 6, perpendicular to the cathode produced similar power density of 1200 mW per square meters. In this study, the space occupied by the anodes was same in all the cases. It shows that the number of brush anodes had little effect on power generation when the volume occupied by brush anodes was constant. If the brush anode size is different, it is unclear whether the MFC performance difference is due to the anode number. If the anode size is changed, the anodic current collector area, the distance between the anode and the cathode, and the anodic carbon surface area are also changed. Polarization resistance. When the number of brush anodes increased, anodic polarization resistance decreased, but not in proportion to the number of brush anodes. Anodic impedance. When the number of brush anodes increased, anodic polarization resistance decreased, but not in proportion to the number of brush anodes. CV analysis. When the number of brush anodes increased, anodic polarization resistance decreased, but not in proportion to the number of brush anodes. In the CV tests, when the number of brush anodes increased, the current productions (IPRO) increased in both the horizontal and vertical anode configurations. The vertical anodes produces a bit more current than the horizontal anodes. The external power supply from the potentiostat during the CV may attenuate diffusion resistance and increase current generation with increasing anode numbers. Engineering implication. Summarizing all the results and discussions, there are the two potential ways to improve best performance. 1. Install a multiple anode set in the horizontal direction along the cathode. 2. Install anodes in the second horizontal direction at a further direction in MFC. 3. Install anodes in both horizontal and vertical directions for BESS with a controlled anode potential. Because the anodes should not be touch each other, the anodes were placed in a zigzag direction in the vertical configuration, and when doing a zigzag placement, the distances between an anode and a cathode would be shortened by 20%. Conclusions. Using brush anodes with the same size, effects of number and configuration of the brush anodes on MFC performance and electrochemistry were investigated. In the horizontal configuration, when the number of brush anodes increased, power and current productions increased, but not in proportion to the number of brush anodes, because the area of the cathode was constant. However, in the vertical configuration, power and the current productions were maximized at the two brush anodes. As the number of horizontal brush anodes increased, the anodic polarization resistance decreased. When a second brush anode was added perpendicular to the cathode vertical configuration, the anodic polarization resistance decreased dramatically. When the number of brush anodes increased, anodic polarization resistance decreased. Introduction of the second brush anode made the largest drop of all the anodic impedance components. In the CV tests, when the number of brush anodes increased, the current productions increased in both configurations. The vertical anodes produces a bit more current than the horizontal anodes, suggesting anode installation methods to improve best performance. 1. Install a multiple anode set in the horizontal direction along the cathode. 2. Install anodes in the second horizontal direction at a further direction in MFC. 3. Install anodes in both horizontal and vertical directions for best with a controlled anode potential. Thank you for your attention. Don't forget to click that red subscribe button and give me a thumbs.